children, so I am back with the second video of the video series on data handling class 8 maths, and in this particular video we are going to talk specifically about double bar graph, frequency distribution table and tally marks. And trust me, these are very simple yet important concepts. So what are we waiting for? Let's get started. Now, we might come across situations where we want to represent two sets of data simultaneously. So that is where we make use of double bar graph. So it is basically a bar graph, but instead of one bar, you have double bars. Now let us take this example. So we will consider the same example throughout to understand the concepts. So let's say the number of students versus their favorite fruits. So this study or this data is being recorded in the year 2014. Now, if you record the same data in 2015, that is in 2015, you do the same analysis of favorite fruits versus number of students. Now, the data will change, right? Because maybe in 2014, 50 of them liked apple. In 2015, it is also possible that only 30 of them like apple. Right? So the numbers would change with time. So now if I say that I want to do a comparative analysis between the 2 years, I want to see how the liking for a particular fruit increased or decreased over the years, over that 1 year from 2014 to 2015. Now the moment we talk about comparative analysis of two sets of data, in that case we will have to represent those two sets of data in the same graph. Only then we can compare, right? Only then it will be an apple to apple comparison. So that is where we make use of double bar graphs, and a double bar graph looks somewhat like this. So here also we draw the same XY axis, but here you see instead of just one bar you have two bars. So one bar, all those bars which are represented in green, they represent 2014, and all those represented in blue represent 2015. Now looking at this double bar graph, you can very clearly say that the liking for each of the fruits have decreased from 2014 to 2015. That means with passage of time, the liking for fruits is decreasing or is reducing. So this is an example of a double bar graph. So double bar graph is exactly the same concept as that of a bar graph. It is just that here we represent two sets of data. So here what are those two sets? One set of data is for 2014, the other set of data is for 2015. So in these kind of scenarios we make use of double bar graph. Now what is the importance of double bar graph? So the first importance is that it helps in comparative analysis. You see, since we are able to plot the graphs for the 2 years in the same graph, so it helps us to compare that how things changed from 2014 to 15. So this helped us to analyze that the liking for each fruit has decreased in 1 year, and the maximum decrease has happened in case of apple, because when you look at the decrease in case of apple, this much decrease is there in apple, whereas the decrease is lesser in mango. The decrease is even very small in case of grapes. It is also quite small in case of banana, but in case of apple, the decrease is maximum. That means the liking for apple has reduced the most in 1 year. So all these kind of interpretations become easier with a double bar graph. Now that we have discussed quite a bit about data, let us now talk about organizing data. Now, the moment we think of organizing data, the first question that comes to our mind is, why organize data? Why do we even need to organize data? So let us try to understand the reason behind organizing data using this example. So what do you see on the screen? You can see a bunch of people, a group of people, a lot of people. Now we have, for the sake of convenience, we have named them as A, B, C, D, E, F and so on. So you have so many people, and there was a survey which was conducted to know which is the favorite fruit of each one of them. Now some of them told apple, some told orange, some told grapes. So different people have different choices. Now looking at this, whatever is there on the screen, if I ask you, which is the fruit that is liked by most of the people, or which is the fruit that is disliked by most of the people, do you think that you'll be able to answer at once? Is it very easy to answer this question? Now here the data is still lesser, because here you only have people from A to R, maybe some 15-20 people. Now if instead of these 15-20 people, you might have a bigger group, you might have a group of 500 people, and all of them telling a specific fruit as their favorite. So how would you decide? I mean, that's difficult, right? Why is it difficult? Because the data that we see on the screen right now is all messed up and haphazard. So what do we need to do? We need to organize the data, because organized data helps us to interpret the data. The information is obtained easily from organized data. Not only that, here when you look at the screen, you see that there are certain data which gets repeated over and again. For example, apple, the favorite fruit apple. Apple is not the favorite fruit only for A. It is a favorite fruit for D, it is also a favorite fruit for F, it is also a favorite fruit for I and J and L. So there are multiple people who said that apple is their favorite fruit. So here in this table, we see that apple is a data that is getting repeated again and again. So now we will make use of these things, these small things that we observe here. We will organize them in a better way when we organize the data. So here we talk about frequency distribution table. So that's a bigger name. You might be thinking that it's a bigger concept as well, but the concept is pretty simple. In fact, this concept is to make our task simpler. So this is the table that we had. Names of people and their favorite fruits. Fine. Now I said that there are certain data which gets repeated over and again. Now the number of times any particular data gets repeated is called its frequency. So for example, if you talk about the frequency or the number of times apple is getting repeated, what would be the frequency of apple? It would be 5, because it is getting repeated 5 times. So now we prepare a frequency distribution table. Now as the name suggests, this would give the frequency of every data. That is the number of times any particular data or any particular entry occurs. So here when you look at the names of the fruits, now there are certain fruits out of which, I mean, like even if there are 200 people, but a lot of them said that the same fruit is favorite to all of them. So what you do is you note down the names of all the fruits that exist in that table. So here in this table we just have 4 fruits: apple, orange, grapes and mango. And then you look at their frequency. Now frequency of apple is basically the number of people who like apple. That's the frequency, right? A likes apple, so apple is here. Again, D likes apple, so apple is here. So the number of times apple is getting repeated means that these many people said that their favorite fruit is apple. So that's how you have noted down their frequency, and this table is known as a frequency distribution table, because this table gives you the frequency of each entry, and here the entries are apple, orange, grapes and mango. Now if I ask you to tell me which is the fruit that is liked by most of the people, looking at this frequency distribution table, do you think that you will be able to answer me at once? Of course, because quickly looking at this table, you can see that apple has the maximum number of frequency, and therefore apple is liked by most of the people. Similarly, mango has the minimum frequency, that is, it is disliked by most of the people, or it is liked by very few of them. So we can say, looking at this table instantly, that apple is the most liked fruit and the mango is the most disliked one. So what did you observe? Now what different did we do? We just created a new table, but this new table is more organized than the previous one. Right? In the previous table, we had, it was like a haphazard table where the same fruit is getting repeated over and again. So we are not able to understand which is occurring more number of times and which is occurring lesser number of times. But now when we make this frequency distribution table, we clearly see that how many times a particular entry gets repeated. So this is the concept of organizing data. So whenever we talk about organizing data, the first thing that we do is we make a FDT, that is frequency distribution table. Now you might ask that what would happen if the frequency is very high, because here the example that I had taken where I said that the entry for apple is repeated 5 times, the entry for mango is repeated just once. So these are smaller numbers, so we can very easily count them. But let's say that if a particular entry gets repeated maybe 30-40 times or maybe 500-600 times, so do you think that it would be feasible to count how many times that entry gets repeated? Not really, because again that would become a tedious task, that would again become a difficult task. But our aim is to simplify the task, our aim is to simplify the entire data so that it can be easily interpreted. So what will we do? So here we introduce a new concept of tally marks. Now what is tally mark? So tally marks are nothing but it's a symbolic representation of the frequency of each entry. Now this symbolic representation will help us, it will make our job a little easier to make the frequency distribution table. So let's see how do we make use of tally marks. Now in tally marks, what we do is we keep the same frequency distribution table, just that we introduce an additional column of tally marks. And in this tally marks, the frequency which we had written as 5, 3, 3, 1 and so on, instead of writing them in numbers, what we do, we just keep drawing lines whenever we come across the same entry. And there is a specific pattern in which we draw these lines. So let's say that we start counting how many times apple occurs. So first time, second time, third time, fourth time. Now when it is fifth time, we cross it. And again we sixth time, seventh time, eighth time, ninth time, and again 10th time we cross it. And that is how we make the tally marks. Now looking at this, so while you are counting the frequency for each entry, these tally marks are the one which you keep drawing so that you do not forget, even if it is some 50-60 times. Now later when you want to fill this column of frequency, what you do, this entire thing would mean 5. Again this entire thing would mean 5. This thing would mean 3. So this is basically 5 plus 5 plus 3, that is 13. So 13 would be the frequency. So the concept of tally marks is basically that when you count the frequency, when you count how many times a particular entry gets repeated. Now, if it is 3, 4 or 5, it's pretty easy. But if it becomes larger, if it goes to 20, 30 or so on, in that case, counting it in hand is little difficult. So that is where you draw these tally marks, and then later you can count the tally marks and then you can enter the frequency for that particular entry. So in this way, tally marks can make our job of counting the frequency a little easier and simpler. So let us make a frequency distribution table. So we will make use of tally marks here. A group of students were asked to say which animal they would like most to have as a pet. The results are given below. Now, there were a fixed number of students in a class, and let's say that they were asked this question. So the first student said dog, second one said cat, third cat, fish, cat, rabbit, dog, cat, rabbit, dog, and so on. Now, what do you observe? So looking at this data that is given here, what do you observe? You observe that there are certain entries which are getting repeated over and again. For example, cat. It exists here, 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 here. And what does that mean? That means that multiple students have told that they would like to have a cat as their pet. And the same is true for other animals as well, because we do see that many animals are getting repeated again and again. So let us first make a list of all the unique entries. So what are the various options that are being chosen by the students? So let us list down the name of all those animals. So dog, cat, fish, rabbit and cow. So these are the animals that we see in this entire set of data. So there is nothing else other than these animals. Fine. So now once we know this, what we need to do in order to make a frequency distribution table, we need to find how many times each of these entries get repeated. Now when you look at this huge set of data, it is very difficult to directly count the frequency. So what we do, we first write their tally marks. So let's say the second column is for tally marks. So let's talk about dog. So the first entry is a dog. Again, this entry is a dog. Again, this is a dog. This is again dog 2 times. So 1, 2. Again a dog. You again have a dog. Again a dog. Dog and dog 2 more times. So 1, 2. Similarly, let's do it for cat. And in cat also we see that there are 10 entries for cat. For fish, rabbit, cow. So for all of these, as we keep counting, wherever we come across a cat or a cow or whichever entry we are counting, we just keep on making these lines. Now once you have drawn all the lines, now it is very easy to find out their frequency, because one set of these lines is nothing but 5. So it is basically 5 plus 5, that is 10. Similarly here also it is 5 plus 5, that is 10. This is 3, this is 4 and this is 1. So this is how we made a frequency distribution table. So let us now talk about grouped frequency distribution table. Now when we already have something like frequency distribution table, why do we need something like grouped frequency distribution table at all? So what is the need of having a grouped frequency distribution table? So this table gives the number of entries in a particular group. So basically here data is represented in groups. Now the idea of grouped frequency distribution table might not be clear only with this statement, that how is data represented in groups? Why is data represented in groups? So let us take an example. Let us suppose that there are 10 students in a class and the score of these students are as given on the screen. Now let's say the names of the students are A, B, C, D, E and so on, and their scores respectively are 90, 80, 81, 42 and so on. So these are the scores of the 10 students in the class. Now you must be knowing that in a real classroom there are a lot more than 10 students. There might be 60 students, there might be 100 students. Now for all those students you might have their different scores. Now if you look at this data, what do you observe? You observe that the scores, they hardly repeat. So most of the scores, for the frequency of most of the scores is 1. That is, they are not getting repeated. They exist only once. For example, how many times do you see 90? It is just once. How many times do you see 80? Again, 80 is also occurring only once. So in this case, the frequency of most of the data is 1. Right? So now if we think of creating a frequency distribution table like how we were creating before, so do you think that it will have much benefit? Not really, because the frequency distribution table is helpful when a particular entry is getting repeated multiple number of times. Only then we have the concept of frequency. But here it is not getting repeated over and again. So what do we do? So in this case, we create groups. Now, what do we mean by groups? So, how do we create groups? Now, what we do is we say that, okay, fine, let us find out the number of students who have scored below 40. So, less than 40 is one group. Again, let us try to find out all those who scored somewhere between 40 and 60. Again, let's find those who scored somewhere between 60 and 80. Again, let's find those who scored somewhere between 80 and 100. So what are these? These are nothing but groups. So now when you ask that how many students scored less than 40. So how many students scored less than 40? Maybe 1. How many scored between 40 and 60? Maybe 2. How many scored between 60 and 80? Maybe 3. So now you have frequency for each group. So even though a particular entry did not get repeated over and again, what did we do? We created a group. So we said, okay, maybe only one student scored 42. But when I say how many students scored between 40 and 60, then those who scored 42, those who scored 45, they came together. So we got that there are 2 students who scored between 40 and 60. So in such scenarios, we introduce this concept of group. So, and this is called a grouped frequency distribution table. So here also we will make use of tally marks like we made before. Here also we will have a column for frequency. It is just that in this case we will have a column. The first column will be for group. So we basically group the data. So we put the data into groups. Like here the groups are 40 to 60 is a group, 60 to 80 is a group, 80 to 100 is a group. So in this way we will divide the entire set of data into groups and then create the frequency distribution table. That is why it is called a grouped frequency distribution table. So let us have a look at a grouped frequency distribution table. So the table would look somewhat like this. So 0 to 40, 1. 40 to 60, 2. 60 to 80, again 2. 80 to 100, 5. So you see that it is a normal frequency distribution table, just that you have divided the data, or you have divided the entry into groups so that you can have some frequency for each of them. Now, when we talk about this grouped frequency distribution table, so here there are certain terminologies which we very commonly use. The first terminology is a class interval. So what is a class interval? Each group is called a class interval. So basically 40 to 60 is a class interval, 60 to 80 is a class interval, 80 to 100 is a class interval. So each of these is a class interval. So that's the term that is being used. So we do not call it group. Now obviously these are all groups, but terminology wise we give it a term called class interval. Upper class limit. Now every class interval will have a lower limit and a upper limit. Like when you look at this 40 to 60. So 40 is the lower limit, 60 is the upper limit. So the upper limit of the class interval is called upper class limit. And similarly, the lower limit of the class interval like 40 is called the lower class limit. Now, when you look at this 60, so 60 is a upper class limit for this interval, but 60 is a lower class limit for this interval. Next is the size of a class interval or a width of a class interval. So what is the size of a class interval? So that is given by the difference between the upper and the lower limit of a class interval. So let us say if I want to find out the size of this class interval. So the size would be equal to upper class limit minus lower class limit, which is equal to 20. So the size of the class interval would be 20. Now the size could be anything, so it depends on what is the value of the lower limit and the upper limit. So these are few things which are related to the grouped frequency distribution table. Now whenever we have to make a grouped frequency distribution table, the most critical part or the most challenging part is to understand how to make groups, is to understand how to decide the class intervals. So that is the most challenging part of making a grouped frequency distribution table. Now, when we talk about these class intervals, now one very interesting concept is this exclusive and inclusive class interval. Now let me give you an example to understand why are we talking about exclusive and inclusive class interval. Now let us say that we have a set of data of the score of students. Now somebody scored 40, somebody scored 42, some scored 92, some scored 63, some scored 75 and so on. Now if I say that I divide this set of data into groups. So let's say that the first group is 40 to 60, maybe the first group is 20 to 40, second group is 40 to 60, third group is 60 to 80, fourth is 80 to 100. So this is how I have divided this set of data into groups. Now, what about this 40? Where will the 40 come? Whether 40 will be included in 20 to 40 or 40 will be included in 40 to 60. So in which class interval are we going to include the data 40? Because in the first interval we say it is from 20 till 40. The second we say it is from 40 till 60. So 40 is present in both these class intervals. So where exactly do I include the data 40? Where do I count 40? So this might be a challenge in a lot of cases. So in order to avoid this challenge, this concept of exclusive and inclusive class interval has been introduced. So let us see what are these. So first we will talk about exclusive class interval. Exclusive. Exclusive is derived from the word excluded, when we do not include something. So what is not included in the exclusive class interval? Here lower class limit is included, but upper class limit is excluded. So that means when you say exclusive class interval, that means if we are saying 20 to 40, that actually means that 40 is not included in that class interval because it is an exclusive class interval. So if you say that this is an exclusive class interval, in that case, this data 40 will not come into this group. 40 will come into the other group because the lower limit is included but the upper limit is not included. So in the first class interval, all those data starting from 20 till 39 will be included. So 40 will not be included. So that is exclusive class interval. So again, let us look at this data. So here this kind of data where we write it as 0 to 40, 40 to 60, 60 to 80. So in each of these cases, the upper limit is not included. So whenever you have a data like 60 or 80 or 40, they will always fall into these. Like a data 40 will be counted in this group, a data 80 will be counted in this group. So it will not be counted in these groups because the upper class limit is excluded. So this is called exclusive class interval. Now let us learn about inclusive class interval. So I hope you would have understood this by now. This means that both the lower limits and the upper limits are included. So in this case, how do we write the groups? This is how we write the groups. So when we say that the upper limit is also included, in that case when you write 0 to 40, so 40 is also included into this group. So the next group should start from 41, right? Because in this case, 40 is already included here. So in this 41 to 60, so 60 is included here. So the third group should start from 61. Again 80 is included here, so the fourth group should start from 81 and so on. So now this is how you distinguish between exclusive and inclusive class intervals. So exclusive class intervals, wherever you have the upper limit of the first group as the lower limit of the second group. So whenever you observe this trend that the upper limit of first group is lower limit of second group, again upper limit of second group is lower limit of third group, upper limit of third group is lower limit of fourth group. So whenever you observe this pattern, that means it is an exclusive class interval where the upper class limit is excluded in each group. But where you observe something like this, where everything is unique, so every lower limit and upper limit, they are unique, they are not similar to any other group, so that would mean that it is an inclusive class interval. Now this, you might think that this is something which I am teaching you which is out of your syllabus, but this is a very important concept because this question might come to your mind that how do I arrange, how do I know that 40 is a part of the first group or it is a part of the second group. So that is why it is very important to understand this concept of exclusive and inclusive class interval. Now here in this lesson, where as we move forward, we will mostly deal with exclusive class intervals. So that's the most common one which we will deal with.
I hope you found the video useful, and if you really understood the concept well, do write in the comment section that concept hua crystal clear. And I will see you all very soon with a new topic and a new video. Till then, take care. Bye-bye.